So, a problem that a lot of people have is, let's grasp what molarity is. So molarity is talked about in chapter 4. It is a unit of measurement. So a higher molarity means a more concentrated solution. So for this problem, we're going to do, let's do a couple molarity questions that would be from the book, so from chapter 4, for my Gen Chem 1 guys. So the question is, what's the molarity of a solution that has 0.175 moles of ZnCl2, so zinc chloride, in a 150 milliliter solution? So the first thing we need to do is define that molarity equals mole per liter, right? So moles per liter of solution. So you make sure that this is the distinction that people are going to make later on, but it's molarity is moles of some of a solute per liters of solution. So since I'm looking for molarity, do they give me moles of zinc chloride? Yes. Do they give me liters of the solution? Sort of, right? So I know that 150 milliliters is actually equal to 0.150 liters, right? So that's just a quick way to save time, or you can do it in the equation if you'd like. So if I want to divide, then if I divide moles by liters, then what do I get? Molarity. So 0.175 moles of ZnCl2 in 0.150 liters. That would be looks like it's a 1.67 or 1.17. Capital M ZnCl2. That's how you'd represent it. I mean, of course, you'd put spaces in between these, but you know, I have terrible handwriting, so. So that's the answer for this one. But the next one throws a little bit more sauce in our pan, which is all right. We can handle it. So it says we have a 6 molarity sodium hydroxide solution. Fun fact, I believe that is what drain cleaner is. So it's very concentrated base. So a 6 molar sodium hydroxide solution, and we want to know how much of that we need in order to get, how many milliliters of it we need to get 0.350 moles. So we actually just need to use this equation to find it. So I am given molarity, I am given moles, I need to find liters. So how do I do that? So you multiply both sides by liters, so you get L times M equals mole, and then you divide both sides by capital M, right? L equals mole divided by molarity. When we write this out, you will be able to see that these will actually cancel out. These units will actually cancel out. So we're going to be using this equation. So liters is going to equal moles divided by molarity. So what are my moles? Moles is 0.350 moles, and I'm dividing that by, and what does 6.00 molarity mean? That's the same thing as writing 6.00 moles per liter, right? That's the same thing. So if I'm dividing this by 6.00 moles per liter, what happens? I'll show you 2 ways to do this, so if this way doesn't stick. Essentially, the moles will cancel out, and then you're left with 1 over liter, right? And if you remember your algebra, this will eventually become liters on top, right? You're dividing by a 1 over. So mathematically, all we have to do, oops, I lost my screen here. All we have to do mathematically is 0.35 divided by 6, and we get 0.058, we'll say 3 liters, and they want that in milliliters, so that's really 58.3 milliliters. Another way that you could do this, if we want to start from scratch, we'll start it right here, is you start with your given, which is 0.350 moles, And then the only other thing that I'm given is 6 moles per liter. And I want to solve for liters, so liters my desired unit. So put liters on the top. So 1 liter and 6.0 mole, right? And then moles will cancel out and you're left with liters, and then you turn it to milliliters. So either way of these is going to help, either way that you visualize it is going to give you the correct answer, which is this. Yay! Alright, so just because I'm fun, I like to have a special. We're going to do a bonus. Get ready, guys. We're doing a bonus. Mystery molarity bonus. So, if you are old enough to imbibe and enjoy alcohol, you'll know that ethanol is C2H5OH, which is the molecular formula for it, and we're going to talk about vodka. So, how many grams of ethanol are needed to dissolve in water to make 1 liter of vodka? So, vodka has 6.8 moles per liter of ethanol. So, how many grams of ethanol make 1 liter? So, a way that we can set this up is start with your given, 1 liter. So, I'm given 1 liter. And I know that, what does this really mean? It means 6.86 moles per liter, right? That's what this really means. So if I put moles on the top, here's my goal. If I put moles on the top, I could turn that to grams, couldn't I? So if I put moles on the top, I could turn that to grams. So 1 liter has a concentration, has 6.86 moles of ethanol, right? You guys with me on this? So how did I start that? How did I know to do it? Well, it says, what are the grams of ethanol? And I say, well, what's a really easy way for me to get grams? I could find moles first. So I'm going to try to find moles. So if I'm given 1 liter and I use the concentration, I can find moles of ethanol. So now I know the moles of ethanol, and then I can, how do I turn moles into grams? So 1 mole weighs how much? Well, I'm going to have to actually do the math here, right? So it's going to be 2 times 12.011 plus, and that's really 6 H's, so plus 6 times 1.008 plus 15.999. So let's go ahead and do that in our calculator. $46.069 grams per mole, right? So 46.069 grams of ethanol for every 1 mole of ethanol. So I just have to multiply these two together and I actually get grams. So that number times 6.86, I get, whoa, that's a lot, right? 316 grams. We'll say 316 grams of ethanol. So in 1 liter of vodka, you have 316 grams of ethanol. Now, the fun bonus question here is, they say, well, why don't we use the density of ethanol, which is 0.789, and calculate the volume that's needed for 1 liter. So if I'm trying to calculate the volume, my end game is to have milliliters right at the top. So I'm given, remember, density equals mass divided by volume. Density I'm given, mass I'm given. I want to know volume. So the equation that I would use for that is volume equals mass over density, right? Because you'd multiply both sides by V and then divide by D. So volume is mass over density. So the mass is 316 grams divided by, and the density is 0.789 grams per milliliter. Divided by 0.789, That's 400, wowzers, 0.5 milliliters. So you know how a liter is 1,000 milliliters? Basically half of it. So 40% by volume is pure ethanol, which is why it's 40 proof, which is the proof system, which if you are not 21, then you don't need to know any of that. But this is another way that we can use molarity in order to solve an additional type of problem. We want to know grams. So in the end, in my head, I say, wait, if I solve for moles, I can solve for grams really easily. So let's say in the end, we want to know how many moles are needed to dissolve in 1 liter to make this concentration. So you just start with your given and then manipulate this given so that you end up with moles on the top. So 1 liter on the bottom, 1 mole, or a certain amount of moles, and then I multiplied it by the formula mass in order to get the mass of ethanol. So I hope that this has helped you practice your molarity.